Hello, okay, so this video is to do with converting decimals to fractions and percentages. Starting off with some nice easy ones, and towards the end of this video we'll be looking at converting some recurring decimals into fractions, which can be quite tricky. But as I say, first of all, starting off with some nice easy ones, 0.12 or something like that. We want to be able, this is obviously a decimal, we want to convert this into either a percentage or a fraction. Now, to convert to a percentage is very nice and easy. So there we go, to a percentage, all we need to do is times by 100. And as we saw from the video of multiplying by decimals, timesing by 100 is actually just a movement of the decimal point 2 spaces to its right. So that would make 12%. Now, to convert to a fraction can be a bit trickier. Some people like to say, well, 12% is 12 out of 100, so then you could just simply write 12 over 100 once you found the percent. But what we're going to do is have a look at another way to do it. So 0.12. So let's look at what these place values are. So this is 0 here, is in the units column. So there we go. If we put like a little u there, on the one on the right hand side of the decimal is the tenths. So that's the tenths, and then the 2 is the hundredths. There we go, hundredths. So in order to be able to convert this to a fraction, all we need to do is set up a fraction. So there's the fraction line, or the division line of the fraction. On the bottom, all we're looking for is the place value of the furthest number, the furthest digit from here. So that's the 2. So that's the hundredths column. Because that's in the hundredths column, I'm going to put 100 there. So it's directly comparable. If it was a thousandths column, I'd put 1,000 underneath. And then all I'm going to do on the top is absolutely ignore the decimal point and the 0 on the left. So there we go, 12. 12 over 100, which is exactly what we would have come up with if we converted it to a percentage first. From here, the story's not quite over yet. We need to be able to break this down slightly, and some people like to just break it down by dividing by 2 and dividing by 3 and so on and so forth. So if we divide both top and the bottom by 2, then that makes 6 over 50. And if we divide it again by 2, that makes 3 over 25. Now, of course, what you could have done is just divide both of them by 4 to begin with, which is the same as dividing it by 2 twice, but that's okay. So that's converting a decimal to a fraction. All we're doing, looking for the furthest most digit on the right, deciding if it's in the tenths, hundredths, thousandths, 10,000ths, and sticking that number underneath. And then we're just going to put whatever the number is without the decimal place. We just ignore the decimal place, which some people might have put as a 0, 1, 2, but 0, 1, 2 is the same as 12, so we just generally don't put the 0 there. And then we just break the fraction down, or simplify is the technical term for it. Simplification into an equivalent fraction. So there we go. That's converting decimals and fractions. Decimals to fractions and percentages. So as promised, the next part of this topic is converting recurring decimals. Now we'll just have a look at what a recurring decimal is. If I say 0.3 recurring, that little dot above means it's recurring. What this is essentially saying is that 3 is going to continue forever. So there we go. It will just continue on forever, and it would never stop. If I have something like 0.32 and I put 2 dots on, that means that it's going to recur between 3 and 2. So it will look like 32, 32, 32, 32, and so on and so forth. If it looked something like 0, 9 with the dot just there, that doesn't actually mean that the 0 is recurring, that means just the 9 is recurring from there on after. So it would look like 0.09 with lots more 9s. There we go. Okay, so that's dealing with what recurring numbers actually are. So if I just sort of shift that out of the way for a second, now we're going to learn how we can convert these recurring decimal numbers into usable fractions. Because those of you that know, 0.3 recurring is actually the same as 1/3. But if we were to convert it using standard ways, then it wouldn't actually work too well. So how do we do this? Fairly tricky, but if you just follow through with me. So we're going to take an example, 0.18, and both of these numbers are going to be recurring. So that, again, just to confirm, that's 181818 and so on and so forth. So the way to do it is say that x is going to be equal to 0.18. So we're going to start to set up some sort of algebraic type equation that we're going to solve. The next step is to identify, if we were to write it out just like this, to identify where the next recurrence comes. So this decimal point is just before the 1, and if we were to move it along, then the decimal point would just be before the 1 again. So that's sort of a two-space movement, which is the same as timesing by 100. So if I times this by 100, what actually happens? Well, 0.1818 times by 100, and we've got the recurrence there, actually makes 18.18 recurring. So going back to this sort of equation here, if I put 18.18, I know that to get from here to here is times it by 100. So I need to do the same on the left hand side. Remember, balancing equations is the most important thing to do, and if we do something to one side of the equation, we have to do it to the other side. So timesing x by 100 makes 100x. Okay, so now what we're going to do is subtract these equations from one another, and something special happens when we do that. We actually remove this recurrence. So I'm going to take the largest number first, as 100x equals 18.18 recurring, and I'm going to put in oops, sorry, no, that's wrong. Put in column order there, just this other one, and what we're going to do is subtract it. So what happens when we subtract 0.18 from 18.18? Well, this whole recurrence bit is removed, and we just get 18. So that's where I was saying something special happens, and we remove that whole sort of recurrence decimal thing. This looks a little bit messy, and all we get is 18. Now we're going to do 100 takeaway x, 100x takeaway x, which is 99x. So 99x equals 18. So from here we can actually write a fraction, because we just need to divide by 99 to get this x on its own. 18 divided by 99. So what is x? Well, this is where we kind of need to go back up to the start. And we said here that x was 0.18. So this is what we started off with. So this x here is actually exactly the same as 0.18. So we're saying that x is 0.18 recurring, but x is also 18 over 99. So this must mean that 18 over 99 is 0.18. From here, what we can do is just simplify into an equivalent fraction. Let me see what we can do is we can divide it by 3, which makes 6 over 33, and then divide it by 3 again, which makes 2 over 11. So 2 over 11 equals 0.18. So we've actually calculated a usable fraction from a recurring decimal. Okay, so that was can be fairly tricky. So what I'm going to do is just be careful and get rid of this bit and try one more example for you. So something along the lines of 0.02. with a recurrence just on the 2. So bearing in mind that this means something like this with the recurrence. So I'm going to write x equals, but this time the x has to be equal to where the decimal point is just before the recurrence. So we actually need to times it by 10. So if we times that by 10, then first of all we've got this, times it by 10, and we get 0.2 recurring because we just moved that decimal there. The next thing that's really important is we need to calculate the equation for when the recurrence, the decimal point is just after the recurrence or just before the next recurrence, which is another times by 10. So it's just pushed it over there once more. So that actually makes 100x equals, oops, sorry, that's wrong, 2.2 recurring. So what's the idea? Why have we got 3 here? Well, the original x was the original number, so that's fine. But then we needed this one here and this one here to identify where the decimal point is just before and just after the recurrence starting. So these are the ones that we're after. So what I'm going to do is set up 100x equals 2.2 recurring, and then 10x equals 0.2 recurring. And from here I'm going to subtract them. So on the left, 100x take away 10x makes 90x. That's nice and easy. And on the right hand side, what we get is 2.2 recurring take away 0.2 recurring. So again, this 0.2 subtracts from that. So we just get left with 2. So from here we can then say x equals 2 over 90, and then x equals 1 over 45, which again, usable fraction, and that's how we do recurring decimals. You can get these examples. They are in the downloadable sheet from the CyberTutor library. Thank you. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah. Would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give it another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done.